Hey, what's going on, guys? Let's do this problem right here. This question is asking to integrate this one using trigonometric substitution. Now let's see how we can do this. But before we do this one, we have to know three conditions. Like whenever we have x square and a number square, we have to take our x value as a tan theta. And whenever we have x square minus a number square, we have to take x is equivalent to a sec theta. Now whenever we have a square minus x square, we have to take x is equivalent to a sin theta. Right? So these are the three things we have to know. Here we have x square minus a number square because this is same as x square minus 3 square. Now x square minus number square, so this comes under this one, the second one, x square minus a number square. Now we have to replace this one with a sec theta. So x is equivalent to a value is going to be this value, that is 3. So this is going to be 3 sec theta. Now we can replace all the x with this value, but we have to do something about dx. Now to do something about dx, we have to take the derivative of this one. So this one is going to be dx. If I take the derivative of this one, this is going to be 3, and derivative of sec theta is going to be sec theta tan theta. So this is going to be sec theta tan theta d theta. Right? Now we can write everything in terms of theta. Now let's go ahead and write that. Here we are going to have, instead of dx, I replace this one. So this is going to be 3 sec theta tan theta d theta on top, and in the denominator we have x square. If I square this one, x square is going to be 9 sec square theta. So that's the one we are going to put right here. So this is going to be 9 sec square theta, and in the square root we have x square again, so we are going to put this one again, 9 sec square theta minus 9. And the first thing we have to try to do in this kind of problem is we have to try to get rid of this square root, right? To get rid of this one, the first thing we can do is we can take the 9 common, but before I do that, I can cancel some of this thing right here. This is going to be 3. And now let's try to get rid of this one. So here we are going to have sec theta tan theta d theta on top, and in the denominator we have 3 sec square theta, and if I take 9 common, this is going to be sec square theta minus 1, right? Now if I take this one outside, this is going to be 3, and 3 times 3, that's going to be 9. So let's take this 1 over 9 outside, because this is a constant, so we don't have to keep it inside. So 1 over 9 outside, and we are going to have sec theta tan theta d theta, and then in the denominator we have sec square theta, and in the square root we have sec square theta minus 1. Now how can we get rid of this sec square theta minus 1 from this square root? Now to do that, you have to know one more thing, that is this one. 1 plus tan square theta is equivalent to sec square theta, and from this one you can realize that 1 minus sec square theta is equivalent to, so this one is here we have sec square theta minus 1, right? So this is actually, this should be other way around. So if I take the 1 to the other side, that's going to be equal to tan theta, right? Tan square theta is equivalent to sec square theta minus 1. So we can replace this sec square theta minus 1 with tan square theta. In that way that we can get rid of this square root. Now let's go ahead and do that one. So let's continue this one right here. So we have 1 over 9. Also, if you notice, we can cancel one of this sec square and this one. So we are going to have this one tan theta d theta. So integral tan theta d theta over sec theta, and in the square root we are going to have tan square theta. Now let's get rid of this square root, so we are going to have 1 over 9 integral tan theta d theta, and in the denominator we are going to have sec theta and also tan theta, and from this one you can see tan theta cancels and we are left with this one. So we know that sec theta is reciprocal of cos theta, so instead of writing 1 over sec theta you can write integral of cos theta d theta. Now this is easy to integrate because we know integral of cos theta is sin theta, so this is going to be 1 over 9 sin theta plus constant. Now we have to know what is sin theta is equivalent to, because our original form is x in terms of x, so we have to write the final answer in terms of x, but here we took x is equal to 3 sec theta, so we had to use this information to find the sin theta value. Now to do this, what we do is we take, if x is equal to 3 sec theta is going to be equivalent to x divided by 3, right? Then if we draw a right angle triangle, and instead of sec theta we can write cos theta, because sec theta is reciprocal of cos theta, so this one cos theta is going to be equivalent to reciprocal of this value, that's going to be 3 over x. Now for a cos theta we know that is equivalent to adjacent over hypotenuse, so here we are going to have adjacent. If this is theta, we are going to have adjacent, that is 3, so 3 is going to be right here and hypotenuse is going to be x. Now we have to find out this value. Now let's say this is for example this is a, and if I want to find this one out we can use Pythagorean theorem. According to Pythagorean theorem, hypotenuse square is equal to a square plus 3 square, so this a square is going to be equal to x square minus 3 square, so a is going to be equal to square root of x square minus 9, so that's the value we are going to put right here. So this is square root of x square minus 9, right? So this is x square minus 9. Now we have to find what is sin theta is equivalent to. So to find that, we know that sin theta is opposite over hypotenuse. Here opposite is x square minus 9. So let's put that right here. 1 over 9, opposite is x square minus 9 over hypotenuse is x. So we are going to have x right here plus constant, and that's going to be our final answer. So let's maybe put it in box. So this is our final answer. I hope you guys find this video helpful. See you next time.